All right, so we're looking at y equals 2x cosine x minus 2 sine x. We're going to finish these up today, so let's see how far. Let's take on differentiate product rule and quotient rule. So product rule. One thing I want to point out before we get too far into this. I know it's going to be very tempting to memorize this as like fg prime plus gf prime. That's fine on the product rule. In a second, we're going to get to the quotient rule. I'm going to show you why that could be a flaw here in just a second. But let's use the product rule to answer this question. So hopefully, and I'm not sure how far I got into the explanation to this. Not much. Okay, I said at least from the last video that we're going to use the product rule here, but not here. Bingo. There's just one function with an x, so it's just a function of x times a constant, so we can just straight up use the rule. So we've got 2x cosine x. Those are my two functions. So when I take the derivative, just so you can kind of see it, I'm going to write it a slightly different way. In this case, f would equal, f of x in this problem would be 2x. G of x would be the cosine of x. So f prime would equal what? 2. G prime would equal negative sine of x. All right, so if we follow kind of the rules, it's the first f of x, 2x, times the derivative of the second function, which is negative sine x, plus the second, which is cosine of x, times the derivative of the first, which is 2. Then, in a completely different color, I'm going to put minus the derivative of 2 sine of x, which is 2 cosine of x. Simplifying that down, my final answer, sure, we'll put it in this color. Negative 2x sine of x. I've got a 2 cosine of x minus the 2 cosine of x. And I'm done. Cool. We did take the derivative of 2 sine x, which is the red negative 2 cosine of x. So when we took the derivative of minus 2 sine of x, derivative of sine is cosine, so it's negative 2 cosine of x. And then, of course, we've got the negative, and then we have the positive 2 cosine of x. Call that a day. Put those together. So quotient rule, not terrible, not bad. We saw, on a question like this, would I probably have quotient ruled this, or not quotient, product ruled it? Sure, not necessarily. This was fairly easy to expand. Came out very simple, so I wasn't worried about that. The only time I'd really find myself maybe using product rule for a question that's two polynomials, if maybe this one's like 3, 4, 5 terms long, this one's like 3, 4 terms long. I don't want to have to multiply 20-something odd terms. I'll just really quick product rule that, knock that question out, call it a day. Pretty good? All right. Now let's talk about my next favorite rule. I will do a derivation of this, and I'll put it up on the thing in case anybody is curious to watch it. That is not a requirement to see it. It's just for the people who are really nerdy and want to know what the derivation of the quotient rule is. The quotient rule looks suspiciously like the product rule for the most part. All right? It turns out to be g of x times the f prime of x minus the f of x times the g prime of x, except it adds one more piece to it. It adds a g of x squared, which makes no sense until you see the derivation where that comes from. So again, I will put that up so you can see where it comes from, but it does actually come out. Now, I was talking about earlier, you probably don't want to memorize this as f's and g's. All right, and the big thing that's the difference between these two is if we just ignore the g of x squared, This pattern is very similar. I can see a GF prime, I can see an FG prime. They're the same things there, but you'll notice in between, now we have a symbol change. And that symbol change is significant because in the top one, in the product rule, did the order matter at which I did it? But in the bottom one, does it matter which one I do first and which one I do second? So in the product rule, we were good. We could just kind of memorize that. The quotient rule, I've got to be picky about how I go through and go about doing the quotient rule. So there's a really, really dumb thing that I use that I learned back when I was in college, and it stuck with me. And then I found out that pretty much everybody in college has learned this one. All right, and here it comes. All right, I don't call this f of x really. I call this the high function because it's up above. And you have a couple options. Some people call it the low function. So you can call it either low, or I like to call it the ho function, because then you got the high ho. And then when you get to say the function, you can say something like this. You can say the ho d high minus the high d ho all over the ho squared. So I remember it, or you could call it low, low d high minus high d low. And when I say d, what am I telling you to do? That's a derivative. Remember when we've been showing you this derivative notation, we're saying that d over dx. So if I say d high, I'm saying take the derivative of the high. When I say high d ho, I'm telling you take the derivative of the lower function. Something different. The reason why that's going to be important, folks, is there will be some questions. Actually, let me just go forward in it. We're going to come back. When I'm looking at a question like B here on this one, this is nice because it's still f over g, but I've seen them in other problems. And this does not seem like that should mess you up. Okay, just change the order of everything, right? But if you memorize it as f's and g's, could you imagine having to then flip and manipulate that entire function, having to go, okay, so wait, so the g is the f, and the f is the g, so the f prime is really the g prime, and the g prime is really the f prime, and then you get really weird inception things going on, and the problem becomes really hard and convoluted and mean. I don't want you to fall into that. So that's why it's important to memorize this as a relationship of the low to the high versus just an equation. So how does this function wind up working out? So let's take a look. We got y equals the sine of x over x cubed. Okay? So the way that we do this, I'm going to try to color code this. So the way we attack this problem, we take the low times the d high. So which one is the low? Times the d high. Minus the high times, I almost lost my color coding, all divided by x to the third squared. Or x cubed cosine of x minus 3x squared sine of x all over, x to the sixth, and you're done. Should we reduce that? No. Feel free. I'm not going to. It's good enough. You could call it, what, x cosine of x minus 3 sine of x over x to the fourth. You don't want to? So just be aware on a multiple choice, could I ask you to do that? Sure. I didn't say you wanted to. I said that the jerk who wrote the question is the one who made you do it. It's not a question of want, it's a question of must. All right. The next two problems, we could use the quotient rule here. In fact, last period I didn't even think about it, and I did the quotient rule to the second problem. We could. Let's go ahead and let's do it. Let's rewrite this as x to the 1/4. So what is this going to be? This is going to be x to the 1/4 times the derivative of 2x minus times should be 1/4 x to the negative 3/4. So what does that become? 2 times x to the 1/4, I can do that. That's 2x to the 5/4 minus something. X squared plus 2 times 1/4 x squared plus 2 times x to the negative 3/4, because I really don't feel like working on that. Now, we could simplify that out. The reason why I kind of paused on that question is, could I have divided x to the 1/4 into both of these problems here? I could actually rewrite this whole problem as x to the 7/4 plus 2x to the negative 1/4. What's the power of being able to do that? Wow, there's a pun in there, and I didn't even intend for it. I don't have to quotient rule it anymore. Just turned it into a power rule problem. That's something I want to instill in all of you. There's a lot of people who force the quotient rule when they don't have to. Now, what you want to do is you want to be aware, just real quick, if I use the power rule for this, this becomes 7/4 x to the 3/4 plus, not plus, minus 1/2 x to the negative 5/4. Does this look anything like this? If I simplify that, would it work? Theoretically. It would be a whole bunch of work to have to do it though, right? And what I want to impose upon you, I can kind of see where that's going. Yeah, okay. But what I want to impose on you on this particular question here is, if we go through and have to do all of that work, and I've got to break all of that stuff down and bring you to this level, you need to be able to look at your answer choices and know which one are they testing. Are they testing my quotient rule questions, or are they looking for a simplified answer? And be aware of both of those, because if you use the quotient, if you use this, but all the answer choices are written like this, you got to look out for that, right? Okay, let's turn the page. I'm going to leave the next example alone. We've already seen one like this. I'm going to leave these examples alone. What I want to do real fast is I want to show you a derivation. Hopefully I can get through 2 of them in the time that I have. So, you should all know what the answer to this question is going to be. The derivative of tangent is secant squared. Secant squared, right? Excellent. So the derivative of tangent is secant squared. If you ever forget that, but you can remember your quotient rule and a couple of trig identities. When I say a couple of trig identities, I'm talking the easy ones, not the hard ones. You too can be able to come up with the answer on the fly. How? Well, because I know that tangent, my first trig identity I'm going to use, can be rewritten how? Did you say the negative? It's the sine over the cosine, right? So now I know that the derivative of this is sine over cosine. And if I use the quotient rule on this, so I'll make sine blue and cosine will be in red here, then I would do what? I would do the low times the derivative of the, so what is the low? That's cosine of x times the derivative of the high, which is also cosine of x, minus the high times the derivative of the low, so that's the sine of x, times the derivative of cosine is all over cosine of x squared. Now let's simplify this. This is really the cosine squared of x, agreed? And negative times a negative is a positive sine squared of x. And where is the other trig identity? Top. Cosine squared plus sine squared is? Go for it, Kiva. He's got the one like in the back of his throat. I don't want to finish it in case it's wrong. So now what do we have? We have 1 over the cosine squared of x, which is, of course, the reciprocal of cosine is secant. Snap. This is why I said sine and cosine are really important to know, because you can do things like that. Yay, sine and cosine. We can also do this with the secant of x. What is another way to write the secant of x? Now this is a really weird, not very often we have to do these, but on occasion we do have to use the quotient rule for questions like this. We can't rewrite this as a power. We can't do any of that. So if I don't know the derivative of secant, and I only know that the secant is 1 over cosine, I'm kind of stuck doing a quotient rule. Quotient rule says the low times the derivative of the high. So the low is, and the derivative of 1 is, minus the high, 1 times the derivative of cosine is, negative sine of x, all over the cosine squared of x. Well, cosine of x times 0, I like that one. And a negative times a negative is a positive sine of x over cosine squared of x. Does anybody remember what the derivative of secant is? What is the derivative of secant? There you go. How dare you look up things in your notes? Wait, using your notes for previous knowledge? Jeez. Secant x times tangent. How the heck do I get secant x times tangent x here? Beautiful. Kevon, were you particularly good at these identities? This is no. Yeah. This is your game. Bam. So this becomes tangent x, secant x. Yay! Could I do the same thing for cotangent and cosecant? Sure. That's about as far as I'm going to take it for those two. All right, that was fun. I'll skip those. We'll see questions like those later. Trying to get through as many of the notes as I can, which means we're going to have to skip stuff. Welcome to BC, where we skip problems. BC, because it's evil. All right. Problems like this drive me absolutely bonkers. Reason being, they're super easy and people miss them on a regular basis because they don't write out the problem. So here's the deal. I give you a bunch of relationships between g, g prime, h prime specifically at 2, and I give you the function values of each of those at 2. I tell you I've got an f of x. It's g of x times h of x. I ask you to find f prime of 2. So what am I asking you to do? Yeah, I'm telling you to take the derivative of f of x, right? So if I take the derivative of f of x, what would I get? This is the product rule. How do I know it's a product rule? Yeah, there's two x functions, right? So we've got a function of x times a function of x, which implies product rule here. So if this is a product rule, f prime of x can be written how? First times the derivative of the second plus the second times the derivative of the Notice I didn't put the x's with it. That's okay. It's simplifying down the notation a little bit. I'm calling them by their function names. So if I want f prime of 2, all I need to know is what is g of 2? What is h prime of 2? What is h of 2? What's g prime of 2? Or 15 minus, or 15 plus 4. Is that a hard question? Anybody want to take a guess at what people will do typically on this, though? No, they will. They'll say f prime is g prime h prime. They're like, what's a product rule? We don't care about that stupid product rule. I don't want to use it. Actually, what they probably did is didn't realize that it's a product and didn't do it. Be very careful. Know when you're doing a product in a problem. Which one do you want to look at, A or B? B? I like B. B's got the beautiful quotient rule built into it. All right. K of x is defined as f of x over g of x. Find k prime of 6 given the graph above. So how can I write k prime of x? K prime of x. Take the derivative of f of x over g of x. I see that there is a quotient, so I need to use the quotient rule. Quotient rule says what? The low times the high minus the high times the d whole all over the whole squared. That's always fun. Now, this is the only information I have provided you. These are obviously counting by 1. How do I know? Because they didn't tell me what else to count by. That is going to be true on all of the tests and such that you take. If I do not define the scale, then the scale is 1. So if I ask you, what is the g of 6? 2. How'd you get that? It tells me. It's right there. It's like, I have this image of this graph just talking to Edwin. Edwin, I'm 2. Yeah, we just look. We follow G. G is the bold graph, so G is 2. What is the f prime of 2? This is the good one. Nope. Nope. It is. Nope. Y'all are just guessing numbers and not thinking, what is f prime? Slope of what? Slope of the tangent line of f, right? So what do you think the slope is going to be? No, not -2. No. -1/2. Were you looking at G by chance? Were you looking at G? Oh, okay. How do we get that? Well, this line has a slope of. Yeah. Be careful with that. And they will ask, this is a legitimate question. I can ask you this. Minus. F is 4. That is -2 all over. Just. So we got -1 plus 8 over 4 is 7/4. Just start using what? No, actually, Stats got in trouble for that. Stats got in trouble for obscene vocabulary because one of the things they used for like years was like So in our class, we'll sometimes use CAT. Some of the class will use an acronym called CAT, Condition Analysis and Theorem, in stats. All right, we're back on. I don't know what it stands for. So I am going to leave you to this one, but I want to also talk about something else. There's a reason why this sentence says if they exist. For instance, at x is equal to 2, we would say that h prime or k prime would not exist. What is the problem at 2 that would cause h prime and k prime to be non-existent? Sharp turns, which means is there really a derivative there? Which means there's no k would also be undefined at 7. Why would k be undefined at x equals 7? K of x, k prime of 7 would be undefined. K prime of 7. What does g equal at 7? So what would I be dividing by? Discontinuity. Why is this all making sense? Stop making sense. All right. Find the point where the graph has a horizontal tangent. All right. Let's see how quick we can do this. How do you take this problem on? I said horizontal tangent. What does that mean? Slope equals 0. All right. Cool. How do I do that? What do we set equal to 0? The derivative of f of x. Okay, so we need to find f prime of x, don't we? What rule do we use? Nope. Why, yes, you could. Quotient rule is perfectly acceptable. Just use the power rule. Why? I could call this 3x to the negative 1 2x negative 2. I can take this x squared and I can divide that into all of my terms. For those of you that need to see one more step with that, do you agree I could technically call this, I did that on purpose, I could technically do 1 over x squared times 3x minus 2. And if I distribute that, that becomes 3x to the negative 1, because I'm going to have x over x squared. And I can call this minus 2x to the negative 2, because I'll have an x squared in the denominator. So now I can just power rule that. So we power rule that mug, call it negative 3x to the negative 2, plus 4x to the negative 3. I'll do some rewriting here. And then I'm curious where you think we go. No, not the 7th period yet. Dang it. Do you agree I can factor out when I divide by 1/2, it's the same thing as multiplying by the reciprocal? So divide by x squared is the same thing as multiplying by 1 over x squared. Okay, then if I distribute that, that's 3 over x squared. That reduces to 3 over x. I did the same thing over here and moved through there. So that's an example of, now, could you do this without doing the power rule? Sure. Totally. You could use the product rule and still get the right answer. But I want you to realize that there's ways that we can do this easily and there's ways that we can do this the hard way. I don't want you to be caught thinking, oh, there's a quotient, I have to use a quotient. Oh, there's a quotient, I have to use a quotient. Modify. Change. Do what you need to do. Understand the situation that they give you. I need to solve this. What should I do? I can get to the answer to this in 3 steps. Checkmate in 3. So what? Yeah, that's too much work. 3 steps. I'm gonna do it in 3 steps, but I'm only gonna write 2. What? That's right. I'm gonna do some creepy math here. 1. Two, 3. Now, 1 should be pretty obvious, right? The heck was 2, 3? How many of you, once you're here, you wanted to say 4x squared equals 3x cubed? Yeah, that's pretty tempting, isn't it? But isn't my goal to get all the x's on one side and the constants on the other? So why don't I just divide the 3 over here, and why don't I just multiply the x cubed over here? Well, why don't we just do that? And then that gives me a 4/3, and an x cubed over x is already... Okay. Ah, you're right, we didn't... But didn't you? Yes, you did. Yes, you did. Now, you were shown it, but you were also given a process to do it. And I want to be very, very, very clear with that. Processes are not necessarily a great thing to know. Processes are a lie. Processes exist because it's something that we can repeat over and over and over again and typically get results, but that also means we probably did more work than we had to. And I am not a fan of doing extra work. Relieve yourself of the processes. Oh, write the equation of the tangent line. Yeah, you can do all of that. Oh, here we go. Cool. Second derivatives. I didn't get a chance to talk about this with fifth period. What is a second derivative? Oh my gosh, we get all sorts of craziness around here. Y'all up for this? Man, we're going to get crazy up in this mug. Second derivative. All a second derivative is it's the derivative of the derivative. Wow. It's the derivative of the 16th derivative. Although we usually don't write that this way. So what you'll see is we have this really neat method of doing it. If I want to write the second derivative, I write a derivative of a function, it's y prime or dy dx, right? Yes. In my notations, of course, the most logical one is the Newtonian style here of f double prime. But this also means the second derivative. The d2y over dx squared. Yeah, it's kind of gross. The third derivative is f triple prime over the d3y over dx cubed. Anybody want to guess what the fourth derivative is? It's f quadruple prime. Although eventually we get bored, and when we get further into the thing where we actually start taking 4, 5, and 6 derivatives of the same function, I think the most we ever hit is I think we hit like the 8th derivative of something. And after we do, well, you get really tired of the tally marks eventually, so you put in parentheses. Yeah, you put parentheses 8, and that means 8th derivative. Yeah, that's pretty cool. So, if I wanted to take the second derivative of f, this is f prime of x is what? I'm going to let the fact that 3 and the 3 will cancel, man. 24x squared over 3. Oh, or x to 2, wow. Okay, there we go. Minus 7, right? So what's the second derivative? Anybody want to take a guess what the third derivative is? 16. No, 16. What's fourth derivative?
Nothing.
It is something. It's 0. Ah, I love those extra derivatives. We can also do the second derivative on a product rule. So if I want to take f prime of x, this is a product rule. Why?
So there's two functions.
It's an x function times the sine of x. So I do the first times the derivative of the second, which is cosine of x, plus the second times the derivative of the first. What? So if I take the second derivative, this is where things get terrible. I have to take the derivative of x cosine of x first. So the derivative of x cosine x is another product rule, because we have a product rule again. Oh, snap. This is bad. So what do we get? We get x times negative sine of x plus cosine of x times 1 plus the derivative of sine x is or negative x sine x cosine x plus cosine x is 2 cosine of x's. And we keep doing it. You just said the first thing. No more. Yeah, I remember in college when they made me do one of those to like the fit. That's basically what it was. That's about it. Ladies and gentlemen, any questions? Folks, I give you a product and quotient rule. Woo! Yeah. All right. Homework is the last sheet in that packet. We should be getting a new packet tomorrow, assuming all the things went the way that I wanted them to do at the printer. So it is the one that's labeled product and quotient rule. Woo! Good luck. Don't fail.